Welcome back to Pratik Academy. In last video, we have studied underdamped vibrating steam. In this video, we will study a simple point. It is logarithmic decrement. So, what is logarithmic decrement? It is simply defined as it is a natural log of ratio of two successive amplitudes on same side of vibrating system. So that means it is a ratio of amplitudes, and amplitudes or two successive amplitudes, and the amplitudes should be or must be on same side. And if we take log of this ratio, then this log is called as a logarithmic decrement, and it is denoted by symbol del. Okay, we have underdamped vibrating steam. As this is the underdamped vibrating steams, in which A, B, C, D are the representing amplitudes corresponding to their cycles. Okay, and we in last video we have derived equation for underdamped vibrating steam as x is equal to a into e raised to minus zeta omega n t into bracket sine of omega d t plus phi. Okay, where this term is representing amplitude of damped system at any instant. So x is equal to a into e raised to minus zeta omega n t, and omega d is the damped natural frequency, and it is equal to under root 1 minus zeta square into omega n. This part we have discussed in last video. Now next, if we want to find out xa, then we have equation x is equal to a into e raised to minus zeta omega n ta. Then for xa we can write as xa is equal to a into e raised to minus zeta omega n into ta. It is time at instant of xa. Then similarly for xb we can write a into e raised to minus zeta omega n t b. Now take ratio of these two amplitudes xa and xb. So xa upon xb becomes a into e raised to minus zeta omega n ta upon a into e raised to minus zeta omega n tb. Cancelling common terms, we get xa upon xb as e raised to minus zeta omega n ta plus zeta omega n tb. Now xa upon xb becomes e raised to zeta omega n into tb minus ta. So what is tb minus ta? Tb minus ta is the time required for a particle performing vibrating steam to complete or to come to its original position, that is on same side. So this will be time period of this cycle by definition. So tb minus ta represents time period of a damped system. Again, this time period can be written as 2 pi upon omega d, where omega d is the frequency of damped system. Again, we have equation for omega d. Omega d is equal to under root 1 minus zeta square into omega n. So putting this value here, we get e raised here 2 pi under root 1 minus zeta square into omega n, and putting this value in equation 1, we get xa upon xb is equal to e raised to zeta omega n into 2 pi under root 1 minus zeta square into omega n. Cancelling again same terms, we get xa upon xb is equal to e raised to 2 pi zeta upon under root 1 minus zeta square. Now taking natural log on both sides, we get log to the base e is equal to xa upon xb is equal to 2 pi zeta under root 1 minus zeta square. Now if you look at this term is ratio of two successive amplitudes on same sides, and we have taken log of this ratio, and by definition it is equal to logarithmic decrement. So this term 2 pi zeta upon root 1 minus zeta square is equal to logarithmic decrement. Now putting this term value in this equation, we get xa upon xb is equal to e raised to del. We have here replacing this value by del here, so xa upon xb is equal to e raised to del. It is ratio of two successive amplitudes of two successive cycles is equal to e raised to del. Similarly for b and c, we can write xb upon xc is equal to e raised to del. Now multiply equation 2 by 3, we get xa upon xb into xb upon xc is equal to e raised to del into e raised to del, and again cancelling common terms, we get xa upon xc is equal to e raised to del. That is, at the same term we get del is equal to 1 upon 2 log of xa upon xc. Here if you look at this, c is the amplitude of a cycle which is coming after two cycles after a. That means we can write xc as xc plus 2 cycles. Okay, that means here we have replaced xc by xa plus 2. Here again, here coming 2. If we have taken a amplitude which is coming after nth cycle, then a general equation will develop, and is equal to 1 upon n log of x naught upon x naught plus n, where x naught is the amplitude of consider or initial cycle, and x naught plus n is a cycle which is taking place after n time of x naught or this cycle. So this is the another equation for logarithmic decrement. Okay. So in this video we have seen logarithmic decrement. In next video we will discuss about Coulomb's damping. Okay. So if you like this video, please comment on this video and share this video with your friends. Thank you for watching.